Now we're going to multiply them. So this is if they have the same index, or in other words, if you're looking for the same root. What you're going to do is you're going to multiply the coefficients, so the number in front of the radicand, or the radical. So we want to multiply the coefficients, and that's going to be the coefficient of the products. Then we're going to multiply the radicands, so the stuff underneath the radical or that root sign, to get the radicand of the product. And then we're going to simplify it out. Because our radicand is probably going to get really kind of ugly, we can simplify that and it should be okay. Let's do this. So first, we're going to multiply our coefficients. We have a 2 and a 6. 2 times 6 is 12. We're going to keep that square root sign. What we're going to end up is 9 times 3. So we actually have 12 times. 9 times 3, well, that's 27. 27, can that be simplified? Well, that's the same thing as saying 9 times 3, which, actually looking at it, that shouldn't even be there. That's okay. 3 times 3. This is why you always simplify before you do anything. So what we can do is we can pull that 3 out. So 3 times 12 times our whatever is left over, which is our square root of 3. 3 times 12 is 36, so we get 36 square root 3. Here we have both of these are cube roots, so we can multiply them. We have nothing in front of them, so we don't have to deal with any of our coefficients. So we'll have the square root of negative 7 times 49. Negative 7 times 49, I actually don't know what that is. That's a great question. But I can tell you one interesting thing. Our 49 is going to split into 7 times 7, so we have 3 of these 7s around here. We can pull out a 7, and we'll end up with a negative 1 inside of it, so we'll have 7 root negative 1. This is an interesting thing. We'll talk about it later, but basically we had to make up numbers to explain what's going on there. So here's our next quick check. Go ahead and multiply these radicals. Take a moment and multiply them out. See, like you should be able to do all of them. They shouldn't have any like hiccups or anything. So pause the video and do that. So let's go over simplifying fractions with radicals inside of them, or in other words, we're going to do some division. So when we want to start on this, we want to simplify the fraction if we can. If we can't do anything to it, then just leave it alone. It's not that big of a deal. We want to rewrite the fraction using the quotient property. So the quotient property says that the square root of a over b is equal to the square root of a over the square root of b. Now this works because if you remember that we had like a over b to the 1/2. Because of the quotient to a power rule, we just end up putting that 1/2 onto both of them. So that's why that works. Our next step is we're going to simplify the square root of a and the square root of b if possible. So whatever is on the numerator we want to simplify, and whatever is on the denominator we're going to simplify, just so that it'll make our lives easier. From there, if we still have a radical in the denominator, we're going to want to rationalize it. Rationalizing is an interesting thing. Basically what you're doing is you're multiplying everything by a really fancy 1, and that 1 is composed of whatever's in the denominator, and you just put it on the denominator and the numerator. So that's like 1. And then you're going to simplify. Let's do an example. So here, remember what we're going to have to do is we're going to have to split this up. So using our quotient rule, we're going to do the square root of 128 over the square root of 8. Square root of 8, well, let's do this. Square root of 128, is there any way that we can simplify that? I'll give it a few seconds. I'm going to pull out my handy dandy calculator because it's fancy and it can do this for me. Square root of 128, that becomes 8 root 4, or 8 root 2. Square root of 8, well, that's going to be simplified as well. That's going to be over 2 square root of 2. What can we do here? Well, it turns out that 8 over 2, these are going to cancel out, so we get a 4 left over. Our square root of 2 cancels with the square root of 2, so our answer in total is going to be 4. This one's an interesting one. 5 root 5 over square root of 4. We can approach this two ways. I'm going to do it the really, really annoying way. we're going to rationalize this, just so that you get an idea of what's going on. We're going to multiply this by a super fancy one. And that super fancy one is just the square root of 4 over the square root of 4. When I mean it's super fancy, just because that a number divided by a number is going to be 1. So what ends up happening here is we have 5 root 5 times the square root of 4 over the square root, over 4. Like I said, this isn't the best way to do it, but it'll work. Square root of 5 times the square root of 4. What we're going to end up doing is we're going to multiply. So 1 times 5 is 5. Our roots, what's going to happen is we have square root of 5 times square root of 4. So we have 4 times 5, which is 20 over 4. We're going to try and simplify that real quick, which will actually end up being 2. No. So simplifying, we'll do it up here. We have 5 times 2 root 5 over 4. I'm going to be cheap here. I'm going to say that 2 and that 4 can cancel each other out, so we end up with 5 square root 5 over 2. The other way you could have looked at this is gone, oh hey, square root of 4, well that's equal to 2, and then just be done because you couldn't do anything else. Let's do this quick check really fast. We're going to divide these radicals. Go ahead and take a moment if you need to rationalize them, and they should be good to go.